Chapter 5, Section 2, or excuse me, Section 6, we are looking at graphing in two variables. Basically what this is graphing inequalities, greater than, less than, greater than or equal to, less than or equal to. So let's talk about the format of this graph. First thing, we have our four choices. We have greater than, and we have less than, and then we have greater than or equal to, and less than or equal to. Because greater than and less than do not include, they are not equal to, they don't include, then those are going to be drawn with a dashed or dotted line, however you look at that. And then the bottom ones, because they are greater than or equal to and less than or equal to, they will be drawn with an actual solid line because they do include the value, and so that will be solid. Kind of like when we started out with inequalities in an earlier chapter and we had open circles and closed circles. The closed circles meant equal to, the open circles meant just greater than or less than. So same thought process, but here we go. We're going to graph a diagonal line, and then I'm going to graph a horizontal and a vertical. So let's go. We'll start with horizontal and vertical. And horizontal, remember, is y only, and vertical is x only. So we might see something like this. Where we've got 2y is greater than or equal to 6. And we're going to go ahead and divide both sides by 2. Oh, having a little board issue there. That's all right. And so that tells me that y is greater than or equal to 3. Okay? And so because it's greater than or equal to, that's going to be a solid line. So I'm going to go to where y is actually equal to 3. And I could put some more on there. Their locations doesn't matter. But every one of those has a y value of 3. And I'm going to pick up a solid line because it does say greater than or equal to 3. Now, here's where things change a little bit. Think to yourself, if I have a horizontal line, maybe it's the floor, okay, which way is greater than? Is it going to be up or is it going to be down? Because we are going to do some shading. And obviously, if you're on a horizontal line, greater than is going to be up. So you will shade everything. I say everything. You don't have to color in every single box, but just show me that you are going, and I say that, and then I color in everything. Yeah. So, and then I have that random black dot there. I get that out of there. So that is the graph of y is greater than or equal to 3. That means every point from positive infinity to negative infinity, from the right to the left and up, all of those points will have a y value that is either greater than or equal to 3. So let's look at a horizontal. Excuse me, a vertical. So a vertical is going to have an x only. So maybe it's 2x is less than negative 3. And so we're going to divide both sides by 2. I didn't really pick a great one, but that's okay. So x is going to be less than negative 3 over 2, which is negative 1 1/2. So I go on my x-axis to where x is negative 1 1/2, and I put a point. And because this is less than, it does not have an equal to, that tells me that I have, if I can get it up here, tells me that I have a dashed line. Now, question is going to be, where do I shade it? So think of number line. A number line goes vertically. Which way is going to be less than? And less than is always going to be to the left. And I won't color in the whole thing this time. All right, so we have to remember dashed line or solid line, and then we have to shade. If it's horizontal, up for greater, down for less than. If it is vertical, to the left for less than, to the right for greater. So now let's look at a diagonal line. So let's go with, we'll just do a basic one. Y is greater than or equal to negative 2x minus 4. Okay, y is greater than or equal to negative 2x minus 4. So the y-intercept of this is negative 4. And my slope tells me that I go down 2. My slope is negative 2 over 1. So I go down 2 and to the right 1. Now I'm going to go up 2 and to the left 1. And get one up here. Okay, so it's greater than or equal to, so that tells me I have a solid line. Now, we have to do a little test. Now, since it's not obvious if it's going to be up or down or left or right, what we have to do is we have to find a point that works. Okay, so what I'm going to pick is I'm going to pick the point 0, 0. And what I'm going to do is I'm going to plug that into my original equation. So everywhere I see a y, I'm going to put a 0. Bring down my inequality. Everywhere I see an x, I'm going to put a 0. And now I'm going to solve it. This is just like substitution from the last couple sections. So that's going to be 0 is greater than or equal to 0 minus 4. So is 0 greater than or equal to negative 4? Think of your number line. Are you better off to be at 0 or negative 4? Obviously 0 is greater. Okay, so this is a true statement. If it is a true statement, that means that 0, 0 is part of the solution. And so I need to shade the region that includes 0, 0. And so I would shade all of this region. If my board was working. There we go. Dun, 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 dun. Okay. Had that come out to be false, okay, had that come out to be false, then I would have shaded the region that did not include 0, 0, which would have been all of this region over here. But it did not come out to be false, so we're going to get rid of that. And that's about 9 minutes worth of graphing in 2 variables, or otherwise known as graphing inequalities.